today's lecture series is a direct outcome of that initiative and is supported by that consortium. Once again, I extend a warm welcome to all of you from CIS Kolkata chapter. We welcome everyone, all participants to this event, to this lecture series 5. And let's make the most of this session beneficial for the researchers, academicians, and explore the deeper into the fascinating world of computational intelligence and its evolving intelligence systems. So now we are going to start the first lectures of today's evening, the power and risk of large language models by Professor Sudeshna Sarkar from Indian Institute of Technology, Kharagpur. The session will be chaired and moderated by Professor Siddhartha Bhattacharya, Chair, IEEE CIS Kolkata chapter. Here, whether Siddhartha sir is with us? Devaditya?
Yes, I'm here.
Yes.
Okay, sir. So, Professor Bhattacharya, welcome, and over to you to start the first lecture of today's evening. Thank you.
Thank you, Somnath, and thank you, Devaditya, for starting the session. It's a privilege, rather, to invite all the distinguished guests over here for this fifth session of this series, which is being organized by IEEE CIS Kolkata chapter as a part of the initiative taken by Professor Tajgupta and leading personnel from TCS. So, before starting on, I'd like to just introduce to the audience our first speaker, in Professor Sudeshna Sarkar of IIT Kharagpur. Professor Sudeshna Sarkar is an accomplished scholar with a distinguished academic journey. She earned her BTech in Computer Science and Engineering from the esteemed Indian Institute of Technology, Kharagpur, and furthered her education with an MS in Computer Science from the University of California, Berkeley. Subsequently, she completed her PhD at IIT Kharagpur, solidifying her expertise in her chosen field. Professor Sarkar's research interests encompass a wide array of cutting-edge areas, including artificial intelligence, machine learning, information retrieval, natural language processing, and text and data mining. Her contributions to the academic community are substantial, with a remarkable portfolio of over 100 publications in prestigious journals and consistent presentations at A-star conference venues. Her dedication to advancing knowledge has been supported by notable research funding sources such as Xerox Corporation, Microsoft, Media Lab Asia, MHRD, and MCIT, underscoring the significance of her work in the field. Currently, Professor Sarkar holds the position of professor in the Department of Computer Science and Engineering at IIT Kharagpur. Additionally, he serves as the head of the Center of Excellence in Artificial Intelligence, further establishing her as a prominent figure in the realm of academia and research. So, with this few words, I would like to invite Professor Sarkar to come on board and present his talk on the power and risk of large language models. Over to you, Professor Sarkar.
Thank you, Professor Bhattacharya, for the kind introduction. We are actually a little early, so let me utilize the time to share my presentation. I think my screen sharing is disabled.
Yeah, one moment, ma'am. Yeah, ma'am, could you please try again? Yeah, it's visible now.
Is it okay?
Yes, ma'am.
Oh, shall I wait for a few minutes because I think it's supposed to start at 6:45, or can I start now?
Whatever, you can start. In fact, you can start because you can take your time and start.
So good evening, everybody. I'm very happy to present in front of this audience. The topic of today's lecture is about the power and risks of large language models for low resource languages, for developing technology for low resource languages.
Recording.
We will first, give a brief overview of what is happening in NLP today and an introduction about large language models. And then we will talk about how large language models enable transfer learning, and especially in the context of multilinguality, how it helps to promote technology for low resource languages. And then we will discuss the risks associated with the use of large language models for low resource languages. If we look at the NLP research over the years, we can see that in the initial years of NLP research, which started from 1950s, the initial work was based on task-specific architectures. And then came the era when people shifted to machine learning and task-specific machine learning systems. And then people looked at pre-training models with fine-tuning. And in today's time, there is more shift to in-context learning with prompts, and both fine-tuning and in-context in one-shot, zero-shot, and few-shot scenarios. So on the other hand, we see that in the task-specific architectures, given examples of input-output label data for a particular task, the machine learning model would be utilized to learn parameters specific to the task, which we can call theta t. Whereas today there is increasingly shift towards very generalized models. So if we represent these models by theta r, reading models or general models, and then these models can be adapted or fine-tuned for a specific task using task-specific models. And over the last few years, we have been progressively seeing that these general models are becoming larger and extremely large, and these task-specific models are shrinking. So that in the earlier era, when we had narrow models, now we have very broad models. Now, the shift in NLP has come because of the power of being able to represent natural language text. And if we look back at the most important landmarks in this domain, we can see that around 2013-14, the NLP researchers came up with word embeddings. So the words were represented by dense vectors, which were learned from unlabeled corpus using simple algorithms called word-to-vec and others, which are love, etc. So the NLP research, when we develop these general models, they have benefited from a paradigm called self-supervised learning, where pretext tasks are defined based on unlabeled data. And from that, a general model is learned. And this general model then can be applied to specific downstream tasks. And this learning of representations has given rise to a vast improvement in the accuracy of NLP tasks. Now, in the beginning, the first work in 2013-14, we had representations of words based on this self-supervised learning, which were context independent. And then around 2018, after the publication of the transformer architecture by Devlin et al. 2017, several language models were developed, such as BERT, GPT, etc., which were able to represent words or text in context of the other text. And these led to huge models, which led to significant improvements on virtually every NLP task. The way that these models were trained were based on simple pretext tasks. For example, BERT was trained on masked language modeling, which is basically you take a text, a piece of text, and you randomly mask certain words, and you have your model predict the masked words, based on which you define your loss function. Another task was next sentence prediction. Given a pair of sentences, predict whether they are consecutive sentences or not. And there were other tasks like permutation and so on. Models like GPT were trained from a simple task of trying to predict the next word. Now, these models got their power from being trained on extremely large size text corpora. And these models also were very large in size, starting with several billions of nodes, neural networks with millions of nodes to hundreds of billions of nodes. As a result of being able to train on very large amount of data on this simple pretext tasks and using a model with an extremely large number of parameters, these models have been found that they are able to encapsulate knowledge from the text on which they are trained on. So we can say that they have some inbuilt background knowledge, and they are able to demonstrate certain amount of common sense reasoning. And they serve as a foundation so that they can be used for various tasks. Now, the particular architecture, neural network architecture, which these models have been using is based on the transformer architecture, which was introduced by Devlin in 2017. In the transformer architecture, the main important component is the use of self-attention, where a sequence of words in a text goes through several transformer layers in the encoder, and at each layer, the representation is computed based on all other representations of all other nodes in the previous layer. So this is the concept of self-attention, which is incorporated into this transformer encoder blocks, and having several layers of blocks, we get a representation. And the transformer architecture had two components, the encoder and decoder. It was initially designed for a machine translation task, where the input is a sentence in a source language and the output is a sentence in a target language. The decoder also uses self-attention, but it can only give attention on the words which have been generated previously. The decoder block also contains attention from the nodes in the encoder block. So this transformer architecture has been the main architecture behind the various large language models. There are three types of large language models that people have developed and used. The first is encoder models, which are useful for representation tasks. An example of this, one of the first examples of this encoder models are BERT, and then there are several other models which have tried to improve on this model. So the encoder model can model language, and the second model is the decoder model, which is epitomized by the GPT model of OpenAI and various other models. In the decoder model is trained on trying to predict the next word, and decoder models are very good in tasks which require generation. And then there's a third type of model, which includes both an encoder and a decoder, which is very good for tasks such as machine translation or summarization, where the input is a text and output is another text of multiple word sequence. Now, these models, as I have explained, is based on pre-training on a large amount of unannotated data, raw data. And these models, once they're trained, we get a general model. Now, this general model, when you want to apply to a specific task, it can be further fine-tuned to get a fine-tuned model. But the idea of any of these models is that you have one one model which can serve various tasks either by itself or after fine-tuning. Now, so this brings us to one of the very important concepts that is being used here. This is the concept of transfer learning. So what is the framework of transfer learning? You have a task on which you have a lot of data, and based on the task, based on that data, you build a large model. And then you have a given task which you have to perform, for which the amount of data is very less. So you can take this large model and add a few new layers or modify certain parameters to do fine tuning so that this model can be used for this task. So this type of transfer learning is very useful when you have machine learning tasks where very little amount of annotated data is available. In the context of natural language processing, transfer learning is used for learning these large language models from raw text. The process is called self-supervised learning or unsupervised pre-training. And then if you have a specific task, you have labeled task-specific data, and supervised fine-tuning can be done. Now, if we look at these large language models, there are different ways in which transfer learning is applied to these large language models. I have already explained fine-tuning. Fine-tuning is done by either adding few layers, few task-specific layers on top of the large language model, or by adapting or tuning some of the parameters. And more recently, a lot of work is focused on prompt engineering, where the large language model is not changed, but you provide prompts or in context, some information. Based on that, you can solve the task. I'll talk more about this later. Now, let us focus on pre-training or fine-tuning. So this is an example of how a language model, large language model such as BERT, can be used for various tasks. So the initial LLM BERT is developed from unannotated data by using tasks such as a masked language model, where you try to predict the masked word and next sentence prediction. And then the same BERT can be fine-tuned for different tasks such as question answering, named entity recognition, natural language inference, and so on. So this is an example of how pre-training is done. You take a text and you randomly mask a fraction of the words, and then those words, those masked words are being predicted by your model, and you calculate your loss based on the probability of the correct word being predicted. And then for fine-tuning, you take task-specific data. For example, for a sentiment analysis task, you can have a few examples of sentences which are labeled by their sentiment. And based on this pre-training fine-tuning paradigm, you can create very powerful sentiment analysis models. Now, I mentioned about prompting and in-context learning. So as these large language models have become bigger and bigger, fine-tuning becomes more of a problem, and it cannot be performed unless you have a very good hardware. Because fine-tuning requires that you take the model, for example, you have to download the model to your computer, and you have to fine-tune the model on your system on the data that you have. So it requires that you have the computing resources to run the model. And then for tuning the model also, because the model is very large, you have to compute the gradient, apply parameter update on every example that you have. This takes time and resource. And this is very expensive to do. for very large models. When you have, for example, the GPT-3 model is a large model with 175 billion parameters. It is not practical for everybody, even if this model is available, to do the fine-tuning. Or even to, if you do not have the model, to train such a model is not possible. So an alternative to this is in-context learning. So in in-context learning, you do not touch the LLM or the parameters of the LLM. Rather, you give examples as context or input to the LLM, and based on the examples, the LLM will try to, given a particular query, it will find the response. For example, if you want to translate from English to French, in the fine-tuning approach, we will give examples, and for each example, the model has to compute gradients and update the parameters. Whereas for in-context learning, you will just give a prompt. For example, give a prompt like translate English to French and give examples of the task. And then you give your query task and you expect the model to provide the answer. And it has been shown that these large language models are able to use prompts and are able to do well in various tasks. And this lets us see that we can use these large language models, which have been trained on vast amount of data as knowledge bases, which capture a lot of knowledge of the corpus on which it has been trained. So we see that there is a progress from earlier we had in the earlier days of NLP or expert systems, we had explicit knowledge, which was used by the models. And now we have implicit knowledge, which is there in the parameters of this large language model. And the major benefit is that this becomes much simpler to use. The model can be on the cloud, and you can provide the prompt and the context, and you can get the response. And the model is also very fast because you only need a forward pass and no gradient updates. Now, these are some examples of results from the GPT-3 paper. So this is an example of how GPT-3 performs on several tasks. So these tasks, like drop is a reading comprehension task where you want to complete a particular, give a particular word for a given question. Then the unscrambling task, word in context tasks. So these tasks, the model has not been trained on this task. However, on these tasks, they show that how the model performs with a few examples when using in context or prompt-based learning. So if you look at the solid blue line above, this corresponds to the performance of GPT-3 with 175 billion parameters. With a single example, it reaches about accuracy of 45%. And as you increase the examples from 10 to the power 1 to 10 examples to 32 examples, it improves. But it reaches more than 80% accuracy on having about 30 examples. So this is how the model with 175 billion parameters performs. But when you have relatively smaller models, such as similar to GPT-3 model, but with 1.3 billion parameters or 13 billion parameters, these are still very large models, but with them, this prompting approach is not so successful. So the ability to solve these tasks, solve these problems or new tasks with few examples emerges as you go for extremely large language models. These are some more examples of showing that how the performance on prompt improves as you increase the size of the language model. So on the x-axis on the left, we have the number of billion parameters of the language models, and the blue line corresponds to zero-shot performance, that is no examples. 1 shot is the green line, and 32 shot, that means 32 examples, is the orange line. And we can see that as the model size increases, the accuracy increases vastly. And also we can see that 0 shot performance is not so good, but 1 shot and 32 shot performance is pretty good. And they can overtake fine-tuned but large with as little as 32 tasks, 32 examples, and with no fine-tuning. And there have been further, further tuning of these language models so that these language models can cater to intended goals and interests. We have Instruct GPT, which uses reinforcement learning in order to be able to do better on a task. We have Chat GPT, which adds to a dialogue, etc. But we'll not talk about these in detail today. But what we see is that these large models have capabilities of doing large-scale reasoning, and this term foundation model has been coined for these large models which have been trained on vast quantity of data. And these large models, it has been found that they exhibit certain properties which are emergent properties when they become very large. For example, these are certain emergent properties of large language models. For example, if you look at math word problems or 8-digit addition, even though these language models have been trained on corpus and they have no idea of these tasks, these models with large number of parameters are being able to do well on this task. So that was the introduction on large language models. I do not know whether we have any questions, but the next topic, which is the main topic of my talk today, is on multilinguality, and I will move on to that.
Can I have a question?
Sure.
So if I'm doing very application specific, use, like, for example, which is the best medicine for pain killing. So do I need this large language model like ChatGPT, GPT-3 or 4, or I can train with only related data set that is medical related or medicine related? I'm hearing that you still need the big language model and then you fine tune for, but my question is, if I'm very specific domain oriented, why I need to have a large language model to plug it in?
Yeah, a very good question. Actually, people are, when you have very specific domains, people are investing in building specific models for those domains. So if you do have a lot of data and a lot of information for specific domains, you could just build a language model on those specific domains. On the other hand, so that is one approach. The other approach is to have a very general purpose large language model, which already has capabilities of understanding language and different ways of using language and different background knowledge, and then fine tune it to the specific domain. Now, there are pros and cons, and people also have tried to make these models smaller, distill those models so that they are better at those specific tasks. The main answer is that if you have a language model which has been truly trained on huge amount of data that incorporates knowledge about the specific domain and also certain common sense knowledge, which is useful even for a specific domain. So, for example, in medicine, people have been trying to experiment with both these types of models. And in many tasks, fine-tuning on an existing LLM helps. But there are a lot of, people are trying a lot to also focus them, make them smaller, make them more suitable, make them less error prone.
Okay,
So there's
continue. Yeah, go ahead.
Sorry, I have a question. This is Kalyan Dev. Yeah, very nice presentation and summary of this large language model. So one question that I have in this is that so this large model, so the model that we are making, and then we are applying it to different kinds of specific problems. So in terms of understanding what the large model is actually learning, so that we can then take that and apply it to various purposes. So is it well understood that when you are training that first large model, what is it that it's learning from the text?
Professor Dev, a very important question. So a lot of researchers are working on this question. So because what exactly is there is not known, because it is in the parameters of the model. And there are a lot of, that's why, I said the power and risks of language models. There are a lot of risks associated with it. And there's a lot of researchers who are trying to understand and interpret this language model, seeing what is there. And also people have to be very careful about the response that you get from these models are not always accurate. So if you are trying to apply it on a sensitive domain such as medicine, you have to be very careful because you cannot trust the output of these models. Mm-hmm. Yeah, so this is this is a particular topic where people are really apprehensive. And after the initial euphoria, this is where a lot of research is being focused on.
Thank you.
This is Saurabh. I have one follow-up comment, actually, not really question. I think what Professor Dipankar Dasgupta was saying is very relevant compared, and also in addition to what Professor Kalyan Dev was saying. I think there are, we already see things like lang chains coming up, where the large language models are, broken up, and specific tools for specific knowledge bases are then added to it, and then the specific questions on that specific domains are then trained separately. Because, or else, for a general model, it would be too many parameters to train in one go.
Yes, I think Dr. Saurabh, that is a very happening area of research where you're trying to inject knowledge into this language models.
Yes, that's why I said it's a follow-up comment.
Yes.
Not really a question. Yes.
So
please proceed.
Yeah, so let me proceed. So my main focus, rather one of the focus of today's talk is to see how these LLMs enable multilinguality. So we know that there are almost 7,000 languages in the world. There are more, but these are languages with more than 10,000 speakers. And we want to develop models that work for more languages so that the language divide can be met, language barrier can be crossed. And also, as we will see, these LLMs and this language technology, when they're being developed, they're catering to high resource languages, and they are going to overpower the other languages. And languages carry with them culture and many other things, and we do not want these languages to die. So we want to first see how to address language technology for these underrepresented and low resource languages. Now, one observation is that many languages, they have similarities in syntax, or they have some shared vocabulary. And today we have multilingual learning approaches that can train these language models on multiple languages by leveraging the shared structure in the input space. So that is, we can have one model which can work for many languages. Now, in this context, I will focus on tasks which require cross-lingual approach. That is, we have some model and we have some low resource language, and we want to do a task on that low resource language. There are various approaches like model transfer, translation-based approach, adapter-based approach, better learning-based approach. I'll talk a little bit about some of them. So first of all, in order to enable this sort of multilingual languages, people make use of multilingual corpus. Now, various language models have been trained on multilingual data. However, if we look at the data, we see that, all languages, we do not have equal amount of data, and they are vastly, there are vast disparities in the amount of data available in different languages. Nevertheless, with whatever data is available, different multilingual large language models have been developed, such as MBERT, XLM, XLMR, MBART, MARGE, MT5, and so on. Just to give an example of one of the earliest multilingual language models, which is multilingual BERT, they combine the corpora of multiple languages and train the BERT model jointly on them, and they use subwords which are common to multiple languages, especially for languages which share the same script. They use common subwords. There have been, we talked about 3 types of LLMs: encoder-based, decoder-based, encoder-decoder-based. For each of the type of LLMs, people have developed different multilingual language models. Some of them do not have fine tuning. Some of them can do task-specific fine tuning and so on. Now, let us first talk about what is the basic way in which we can handle cross-lingual tasks. So there are 2 approaches here which can be combined. The first is multilingual training, where you have a single model as above, and which is trained on multiple languages, so that we can get a single model that works on all these languages. The second is cross-lingual transfer, where a model is trained on high-resource language, 1 or more high-resource languages, and the initialized model is then fine-tuned on a small low-resource language, and we can combine both of them. So we have already said that multilingual training is affected by various multilingual language models, which we call massively multilingual transformers, or MMT. And then cross-lingual transfer is fine-tuning these MMTs for NLP tasks. And there are several scenarios, 2 scenarios. One scenario is zero-shot cross-lingual transfer, where you have no labeled data for the low-resource language. For the given task in the low-resource language, there is no labeled data. That is called zero-shot cross-lingual transfer, or ZSXLT, and few-shot cross-lingual transfer, where you have a few labeled examples. However, by taking advantage of this pre-trained MMTs, one can achieve some amount of performance on these tasks for these low-resource languages. Now, to illustrate zero-shot cross-lingual transfer, suppose we have a task X and you have data for a language A only, and you have a language B for which you have no data. Can you build a model that can make predictions for X in this different language B? So this zero shot is enabled by this multilingual language models, which have been trained on very large amount of corpora, but the performance varies substantially for different target languages. Especially if we look at the performance on different target languages, if the target language is somewhat similar in syntax or other ways to the languages on which the model was trained, they perform much better. But if they are distant to the original languages, they do not perform well. So, for example, in Indo-European language families, many languages perform reasonably well under this scenario. But for other families which are less represented in high-resource languages, they do not work so well. Then we have few-shot transfer, where you have a few task-annotated instances in the target language. And you can do large, in few-shot XLT, you can have large-scale fine-tuning in the source language for that task using task-specific label data. And then you can use the few examples in the target language. But this few-shot XLT is very sensitive to the if you have few examples in the target language, you have to be very careful about the quality of the examples, the number of examples that we use, and it's not that always using a larger number of examples help. The quality of the examples matter a lot. And these methods typically work well for tasks which are slightly require lower level of language processing, like part of speech, NER, but not so well on tasks such as natural language inferencing or paraphrasing. Then there have been methods which adapt to the target language. When you are building the language model, you have a general language model, but then you have certain parameters, few parameters which are task specific. So typically these language models have huge number of parameters, but few number of parameters you make which are specific to the task. I'll not go into the details. So this shows an example of a transformer block where you have added a few small modules corresponding to a different language or a specific task. Another approach, again, I will not talk in detail about it, is using meta-learning. So in meta-learning, what happens is that you learn a good initialization of the model for adapting to different languages. Use multiple tasks to obtain the initialization of the parameter, and then use the few samples to adapt to the new task. So we have done some work on using meta-learning for tasks like cross-lingual question generation, then for event detection, etc. I'll not go into the detail. Another very important model that we are using now is based on prompting, as we have discussed before. So in prompt engineering, the objective is to find a prompt that you have to give to a language model so that it can solve for this particular task. And in the multilingual or cross-lingual scenario, when you develop these prompts, in a few shot or zero shot case, there are various design choices. And based on the design choices, one can find out what works well. For example, the few shot examples that you have may be in the high resource language like English or in the low resource language. The test examples can be in the native language, or they can be translated from the low resource language to English, and so on. And based on that, there can be various performance on these tasks. Now, in summary, we can say that these multilingual language models enable multilingual language processing by virtue of their shared architecture, which can handle multiple languages. This architecture is language agnostic, and they're pre-trained on large and diverse multilingual corpora. And it allows them to capture linguistic patterns and features from various languages simultaneously. And the shared architecture serves as a foundation of multilingual understanding. And these large multilingual models can benefit resource-poor languages because they serve as a starting point for NLP tasks in such languages. So if you want to work on these low resource languages, you do not need to, for every task, collect a lot of label data, but you can make use of this model and few label data to perform relatively, reasonably well on these tasks. Now, this shows how well these multilingual models cater to those low resource languages. But next, we will talk about what are the challenges and risks associated with these multilingual models. Now, if we look at these multilingual models, if we look at their data and linguistic coverage, so we have taken, the slides are taken from a tutorial from Microsoft Corporation. So we can see that this is the multilingual model XLMR, this is GPT-3, Bloom, Palm, these are all well-known multilingual models. We see that the data on which these models were trained are very skewed, and some are more skewed than others. For example, in XLMR, 19% of the data is in English, and the representation of the other languages. Bloom, 30% is in English. GPT-3, 93% is in English, etc. So Common Crawl is an open source corpora in multiple languages, and we can see that the vast majority is in English and much less representation from the other languages. Even there, the ones that we see are only a small fraction of the 7,000 or 400 languages that we really have. We also see if the language is not present in the language model or in the data on which these language models are trained, on those languages, this cross-lingual training does not work very well. Also, if a language is poorly represented, the performance also suffers. So there have been various experiments, and people have found that for a fixed size model, if the multilingual model, for those languages which are represented, if the multilingual model is trained on a large number of languages, the per language capacity decreases with the increase in the number of languages. So we can summarize some of the shortcomings of these zero-shot and few-shot models. They have limited language proficiency. They may not perform as well as language-specific models on models fine-tuned on a particular language. The fluency may be low. Secondly, the cultural sensitivity and nuances are lost, because these models, we know that different languages come from different cultures and they capture different cultural context. In the same context, depending on the culture, if you have a sentence completion task or a task, the answers will be different in different cultures. So these models, because they have higher representation of certain languages, they overpower those languages for which they have less data. And they do not therefore capture the cultural sensitivities, context, or nuance for these low resource languages. And they may generate content which is culturally inappropriate or insensitive. Then they may not perform well in domain-specific or highly technical context. Now, if you look at multilingual performance of these language models, they depend on they depend on the corpus used for training. What is the representation of different languages in the corpus? Also, it depends on the type of the corpus. If the corpus is monolingual, independent corpus in the different languages, the performance is not so good. But if you have a corpus which is based on parallel data between English and that language, then training on that corpus gives a better quality multilingual language model. And it is even better if you have sentences in the corpus where you have the low resource language translated to English, as well as English translated to low resource language. Then the post-training instruction fine-tuning also matters. If the prompts or the examples that you give are only in English versus if you have prompts in the particular language, etc. So, these influence the quality of the performance on low resource language for this multilingual language model. And this is where people are trying to understand this and trying to see how these effects can be balanced. So some results I will state. This is a benchmark called Extreme, which was created to cover 40 different languages belonging to 12 different language families. And they took 9 tasks that require reasoning about different levels of syntax or semantics. And in Extreme, and they focused on trying to find the performance of zero-shot cross-lingual transfer, where annotated data is only there in English, but not in the target language. And they find that these LLMs come close to human performance in English, but performance drops significantly in other low resource languages. And performance differences are lower for simple tasks like part of speech, NER, etc. And their differences are highest for syntactic tasks, sentence retrieval tasks, etc. Also, it has been found that the models do better from the Indo-European family, for languages of the Indo-European family, which are better represented in this language models, unless they do not perform well on language families which are not so represented, like Sino-Tibetan, Koreanic, Niger, Congo, etc. So this is a snapshot of some results which illustrate that. I'll not go over this. Also, the corpora quality matters a lot. Now, most of the research is, most of these LLMs are culturally English-centric. But when you want to develop corpus for a low resource languages, there are various options. The simplest option that people often adopt is to scrape articles from the web. So in a low resource language, if you scrape the web, you get some documents, and you can try to incorporate that in the language training, or you can have a document in English or some other language and ask a native speaker to translate them to the low resource language, or you can ask the native speaker, given a topic, to write the own paragraph. Now, it has been found that online scraping does not do well, and writing their own paragraphs can be better alternative for collecting data of extremely low resource languages. The reason is that, when you collect data from the web or you do translation, you lose the cultural context of the native speaker. So it is better to, use data, even if you're using low amount of data, one should use data which captures the cultural context of the language. It has been found that LLMs do not generalize well to unseen languages. So it is very important to address these problems and generate LLMs which are more sensitive to these low resource languages and which are more language inclusive. So these are the challenges and strategies in cross-cultural NLP. So if we want to work on multilinguality, one has to be sensitive to the needs of the cross-cultural and multicultural NLP needs, and consider these differences to better serve the users of the NLP system. I'll conclude by summarizing the risks of multilingual large language models. There are translation errors for low resource languages, which can lead to misunderstanding, miscommunication, etc. LLMs might discourage language preservation for endangered languages. As language technology caters to high resource language, there's a tendency to use them more, or instead of developing your own article in your language, there's a tendency to use machine translation system which generate non-fluent language. Thirdly, LLMs may exacerbate language inequality because they are primarily trained on major languages. They perform better in those languages, but the results in less common languages are not so good. But in general, there are other risks of LLMs, which they can contain misinformations or inaccurate data. You cannot trust the output that they produce. They amplify the bias which is present in the society, and because they are incorporated into the LLMs, their output also contains this bias, and they can be multiplied, and they can also be transmitted to other languages. There are privacy concerns, there's lack of accountability, no human interaction, etc. And so it is very important to establish guidelines, ethical principles, and responsible AI practices when developing these multilingual models, which should address bias. There should be model transparency. And we all know that ethical and responsible AI development is crucial, and that is also true in this sphere of multilinguality. With this, I will stop. I'll take questions.
Anybody having any query, you can just either unmute yourself and also write on the chat box any query you have.
So again, I'm getting back to that. So, the way that large language models collect the data and without proper reference and violation of copyrights, do you think it will be sustainable in the long run? again, it seems it is like a Wikipedia in a large scale where data authenticity, data validity, legality is totally unknown. So do you see that in future, the smaller models, task specific, and companies will pick up those and like real estate business? I gave another example. So where there may not be enough data in the general model, and there is a huge computational cost. Some millions of dollars. The report was on ChatGPT for training, and more and more people are complaining about not giving the correct result because it is difficult to make specialized training. It is more generalized, and the term came from industry called hallucination. In our time, we used to call it is an error by the model. What do you think?
So, Professor Dashgupta, you have raised several very important questions, which people are, like copyright violations, privacy. These are extremely important issues which have to be addressed, because otherwise, there will be many legal issues and other issues. So definitely they have to be addressed. But however, the sort of power these large language models have, I do not see that, they will not be useful. So I'm sure that once these legal issues, those sensitivities have been brought into place, these large language models will continue to thrive. There are various points. I may have missed some points. Another point is that you asked about specific models. Yes, specific models have their value in specific domains, but then, you do not have sufficient, you may not have for all domains sufficient amount of information for having the good specific models. That is where large models are useful. Yes, costs is a very important factor in the amount of energy, the amount of costs is a very important factor. But we see that there are various abilities which only emerge when you have these extremely large models, which are not there in moderately large models. So extremely large models have some benefits which people have seen. But definitely, smaller, lightweight models are more practical, and trying to distill the models, trying to make this, inject knowledge into the models, make them interpretable. These are all aspects where, active research is going on and a lot remain to be done. So I definitely think language models have their values, but they have a lot of risks and shortcomings. About hallucinations, once, the users understand that these language models can make errors. So it depends on how you use them, how much you trust them. So, they can still serve as important tools, but if you use them blindly and that is not possible. So there's a lot of, you have to understand what are the risks associated with their use, what are their capabilities, and use them in a responsible manner. And also, I think, as you said, research into various of these aspects are very useful. Did I miss anything?
Thank you. No, that's good.
There's another small point that I have actually shared a link in the chat. Japan is actually investing billions of dollars to redo the whole thing in a native Japanese language model, because they have realized that a lot of nuances are missing in general ChatGPT. And what you said is very interesting, because a lot of different other languages are translating and learning, but it doesn't work for Japanese. So the companies in Japan, NEC and SoftBank, are putting a lot of money in terms of billions of dollars to redo the whole thing and train it in Japanese language. And I've shared a link in the chat room.
Yes.
It's a Scientific American article about why Japan is doing this. And that actually touches a lot of the points you have touched today in your talk. Japanese is not a low resource language. It is actually a very high resource language,
High
but
resource.
it's not known to the world. That's the thing.
Yeah, it's high resource, but I think still, there's a gap between the Japanese language and Indo-European languages because the scripts are different. If you look at Roman script and Japanese scripts, are very different. So on these types of languages, the general LLMs do not work well. While Japanese is a high resource language, even relatively, the main problem I see is that even you take a relatively high resource language, I mean, I do not know so much about, what is available in Japanese, but if you look at Indian languages, for example, they are not very high resource. But the other problem that we see is that the domains where you see Indian language documents are available, they do not have documents on every domain. If you look at different technical domains, there's not so much of presence. So that is where, cross-lingual, helps. And also it's definitely important that the languages have their share. I know even Swedish government, they are developing their own language models. So, but it is also useful, while you should be aware of the risks of using English-centric models, it's also useful to use models of other high-resource languages because the knowledge available there, you want to combine your own knowledge with the knowledge available in other languages, but you also want to preserve the individual identities of different languages and cultures. So not just languages, if you think about dialects, there are so many dialects, these dialects are also overpowered, dialects are lost when you put them into one language model. For example, Bengali has various dialects, but my guess is that if you combine them and learn a language model, the identities will be lost. It will not be easy to get those separated out. So,
sorry to cut you, but even with the dialects, the underlying grammar is universal in a language, though.
Grammar is not universal. There is, grammar is, but different languages are different.
No, within a language.
Grammar,
I'm saying within a language.
Within a language, the grammar.
So how come dialects will matter?
Because there are different things. One, in the dialects, the word forms or the word forms, the way of saying, it's the cultural context. How you say, what you say, those things are different in different dialects.
I see. Mm-hmm.
Yeah, dialects may have the same grammar. I'm not sure whether dialects can have different grammars, but the word forms differ, the cultural contexts differ.
Right.
The lexicons differ.
Yes.
I think we should move on to the.
Thank you, madam. Thank you, Professor.
Thank you very much
for your enlightening speech. And we'll be moving on to the next speech, which Professor Dr. Shouro Rai of Flipkart. The title of the talk is "Why do we need data science in e-commerce?" Before moving on, I would like to just introduce Dr. Shouro Rai to the audience. Dr. Shouro Rai is a distinguished professional with diverse educational background and a wealth of expertise. He earned his bachelor's degree in computer science and engineering from Jadavpur University and pursued his master's degree at the prestigious IIT Bombay. Later, he went on to achieve his PhD at the esteemed IISc Bangalore and complemented his technical knowledge with an MBA from FMS Delhi University. Currently, Dr. Rai serves as the Senior Research Director at Flipkart, leading e-commerce giant, as an ACM Distinguished Member and President of ACM KDD India chapter, IKDD. He is deeply involved in the academic and research community, contributing to the advancement of knowledge in this field. With an impressive portfolio, Dr. Roy has authored over 100 peer-reviewed papers published in premier journals and conferences. His intellectual prowess is further underscored underscored by his ownership of more than 30 granted patents. In his current role at Flipkart, Dr. Roy leads the charge in supply chain and demand forecasting and planning technologies. His responsibilities encompass data products, data engineering, and applied data science, which play a pivotal role in enabling e-commerce operations to thrive at an ever-growing velocity and scale. So let us welcome Dr. Shourab Rai. Over to you, Dr. Rai, for your speech.
Thank you, Dr. Bhattacharya, for the generous and kind introduction. It is a pleasure to be here in this forum, in this prestigious forum. I appreciate Arijit reaching out to me and inviting me, and I because of scheduling conflicts, I had to decline a couple of times, and before I could manage to come here, I'm very glad that I'm getting this opportunity to talk to all of you. I'll share my screen. Let me just put that out.
Yes.
Okay.
Yes, it is visible.
My screen in full screen?
Yes, it is visible.
Very good. Okay, great. Thank you. Okay, so the title of my talk is it's intentionally a bit provocative. So essentially the question is, why do we need data science in e-commerce? Probably it's hopefully the answer is yes, but hello. Yeah. Hopefully hopefully all of us are convinced already that this is the answer is yes. But what I will try to do is that I will get into some examples and details of the to make sure that the case is more convincing, and at least to get something out of it, that to know that okay, how e-commerce is leveraging data and data science in broadly speaking. So just a quick, there's one context setting background slide, right? I mean, the growth and spread of e-commerce is not unknown to this group of audience. And it has been a steady story over a decade or so across the world, definitely, and also in India. And in particular, the last 2 years, during and post-pandemic, have been even steeper rise that we have been able to kind of see. So essentially, not only we have all become the regular users of e-commerce, but e-commerce companies have almost become the everything store, which is essentially anything and everything that we need, we try to go there and find it. And essentially what I was reading somewhere, that 2/3 of the product buying intent actually starts from e-commerce website searches rather than from web searches generally. And riding on this journey of e-commerce over the last 1 or 2 decades, I mean, while it started off with the intention of digitizing product transactions, but not only they are doing that today and over the last few years, they are inventing new ways of doing commerce. And a lot of these are essentially becoming like the ways of doing commerce the way we do, like this social commerce, video commerce, and so many of these things that you might have heard about it, right? Now, while the growth of e-commerce is also is largely, while the e-commerce as an industry was born digital, right? I mean, it's the name is e-commerce, so it was born digital, but the growth has manifolded by spearheading, by leveraging software and communication technologies in the first place, essentially building on the software mechanism to kind of enable these things. But more significantly in recent times, by leveraging data, and hence the data-based insights or data-based applications have become more and more prominent, that in a way that today we cannot even think about an e-commerce operations without which is not leveraging the data that it is generating, right? So that's broadly the general context in the e-commerce, how it is growing, and so on. Now, with that, broadly what I will be talking about, this is the broad structure. It's not a very standard talk, but I thought that I'll talk about it. So I'll first talk about some of the trends of e-commerce in India. And I'll present some statistics which are hopefully will be kind of quite revealing to you. Then we'll look into what I call a bird's eye view of a large e-commerce platform. Like, what does it take, or what does it entail when we talk about an e-commerce platform, a technology platform, right? Then I'll deep dive into a few of the areas of the data science innovations in e-commerce, and each of these I will try to talk about, like why do we need such a function? What are the data science opportunities, and why is it a challenging problem to solve those, right? Many of the examples that you will probably see are kind of solved problem, quote unquote, or have been well researched over the years. But why are these challenging still in the context of when we are talking about e-commerce? And then I'll talk about touch upon a few state-of-the-art data science research outcome papers for each of these areas. Right? This talk will be quite broad and will be very application oriented, not very deep, and except maybe some references to deep learning that I will make. Just wanted to kind of let you know. And also another disclaimer these days I give is that there will not be any generative AI related content, because that itself is a one or multiple talks. So I'll not be touching upon that, though there's a whole lot of things that are going on in that space as well. And I will be using these terminologies AI, ML, data science interchangeably, which is incorrect. Yeah, but I'm just doing it for convenience. Yeah. And of course, while this talk is broadly based on publicly available content, but definitely I have learned a lot from my colleagues in Flipkart, and just wanted to acknowledge them as well. So as I was talking about, right, that I'll start off with some India context, right? So India's this e-retail market, or this e-commerce market has been growing pretty significantly, right? And as you can see, like in 2021, it grew significantly over the last year due to COVID-19, but the growth continued even if fortunately the pandemic went away, and it is projected to grow at a similar or a steeper rate in the coming years, right? So it's like currently maybe about $50+ billion market. It's projected to grow about like $150 to $170 billion market in like 2027 in India, right? And one of the things I should have mentioned in the agenda, that I have some small quizzes and in between slides, just to make sure that in a virtual setting all of you are with me in that. So these are like guess questions essentially. So the first one I'll kind of start off with that is that, so the numbers that you see at the bottom, the penetration percentage. So this penetration percentage refers to the fact that how much of the overall retail market in the online plus offline, how much of it is served by the e-commerce business, right? So you can see the representative numbers in China, which is around 26, 28, 30% in the current time frame. So my first question is that what percentage do you think is the penetration in India? You can just unmute yourself and just call it out. It's a guess question. What percentage of overall retail market in India is served by e-commerce?
It could be like 10 to 15%.
Okay, any other guesses? 10 to 15%?
Near about 25%.
I couldn't hear that well. About 5% what I heard. So mostly you are in the ballpark range. So essentially we are currently about at 5% range, and we're looking at a growth with the kind of growth that we're talking about. We're looking at reaching up to about 10% by 2027. So essentially, I mean, from a business perspective, it's a big market, and e-commerce is poised for even steeper growth in the coming years in the Indian context. Now, where is this growth coming from, right? So if you see that Indian online shopper base the digital shopper base, right, that itself has been growing, right? So 105 million to 140, 180, 90 million in 2021. By 2027, we are expected to close to 500 million of people who are online shoppers, right? Every year we are adding like 50 million online shoppers every year. Well, that growth is kind of similar to what we saw in the business growth. But another interesting part is the right side of the funnel that you see. So what it shows is that what fraction of the people are using in the digital domain, right? For example, the chat and social media has about 450 or 500 million people already. Video content is about 400 million. Service transactions, right? UPI and payment transactions are about 250 people. And the product transactions are about less than 200 million people, right? So basically what it says is that the 60% of the people who are already using social media and already in the digital funnel, they're still not using e-commerce, right? And there are various barriers when we actually think of making product transactions and so on and so forth. So essentially the point that there is a significant headroom of already digital users, right? So the barrier is not in coming to actually telling people that, okay, how to use a mobile phone to do certain things, but to actually see that how do you make people more comfortable in terms of doing some of the product transactions on these using their phones and other devices, right? A lot of these new shoppers are actually coming from more like the breadth of Bharat, essentially like the non-metro, non-tier 1 cities. So more than 60% of the new online shoppers are coming from tier 3 or smaller cities. And the new generation of digital natives who are born with the digital, I mean, they're the born digital generation, like they are already like in big time in the e-commerce domain, because that's the natural way of they are doing shopping. And like less than 1 in 3 shoppers is like the less than 25 years of in that range, right? Of course, they also bring in this new, these are diverse group which serves our diverse needs come. There has been a deep logistics development that has been going on because India is a diverse country. The spread and depth and breadth of India with a lot of, I mean, non-standard infrastructure across the country produces a lot of logistical challenges. But again, there has been a lot of technological innovations, both data and non-data driven, to lower the fulfillment cost, etc., to achieve, which is automation through automation and increasing scale, right? Today, like more than 99% of the pin codes are served through e-commerce vendors, right? We have pretty much reached every part of the country through e-commerce channels, right? And of course, it has opened a lot more shopping window for people across the board. And finally, it's not only the consumers, right? It is the online seller base is also growing very rapidly, right? I mean, we see like about 35% year-on-year growth in the online seller base, where for them, like it's they are not only bringing a deeper and wider catalog of products for consumers like us to actually shop from, but also for sellers, it's a value proposition that this is an incremental sales channel for them beyond that what they were doing, right? And there have been like very, very motivating stories that are there where sellers from very distant part of the country have been empowered through the e-commerce to be able to do business on this, right? So overall, it's a very steadily growing and big story that is kind of evolving in the e-commerce space in the India. And so that's the point I wanted to drive in here. But all these growth numbers, etc., are fine. These are business numbers. These are growth from industry-specific numbers. But I mean, we may wonder, right, that what's the big deal in an e-commerce platform, right? So you have a bunch of people who are selling stuff. There are a bunch of other people who are buying stuff, and there's a website, there's a mobile app, which are connecting them, right? And maybe you have to provide some payment gateways, and you have to manage the delivery of people and through some courier service, etc. What's the big deal in developing an e-commerce platform, right? Now, and if we double click on this black box, there the diversity and the complexity of this comes out. And if there is any one thing that you may want to take away from this slide, I would probably from this talk, I'll probably say that this is this one slide that I would like you guys to kind of keep in mind, that it's a huge ecosystem of technology that goes into to build a large-scale e-commerce platform. Now let's just walk through this, right? And we'll try to kind of decipher this complex-looking picture. So basically, what you see in the gray box in center is the different components of an e-commerce ecosystem. What is it doing? It is connecting a bunch of sellers to a bunch of consumers. There are different types of sellers, from large businesses, small and medium enterprises, wholesalers, direct to consumer brands, and so others. Similarly, on the consumer side, you have these different types of consumers, like metro and tier 1 consumers, tier 2, 3 customers, kirana stores, resellers. So I mean, there's a variety of people who are kind of buying and selling stuff on this platform, right? And in large companies, in large e-commerce platform, the scale is also huge, right? So for example, there may be hundreds of thousands of sellers who are selling stuff of this different variety to hundreds of millions of consumers on the other side, right? So it's not only a diverse matchmaking problem, but it's a huge volume and high scale matchmaking problem. Now, what kind of things that happens inside this, right? So these various boxes that you see inside, so these are essentially different. You can think of these as software modules, but of course, again, in the large context, this could be large groups of large departments or large groups of software engineers, product managers, data scientists, design experts, UI developers, and so who actually compose of each of these, right? Now, some of these components are more consumer-facing component. For example, search is a very basic thing that the e-commerce needs to provide for consumers to actually look for products that they're doing. While initial days of e-commerce search kind of got inspired from web search, but over a period of time, very, very nuanced applications of search or aspects of e-commerce search evolved, where a lot of e-commerce specific search innovation happened, which are beyond the beyond the realm of, say, web search. Similarly, the consumer facing other components like payments, advertisements, like how do you actually make sure that as consumer I'm actually able to see the relevant ads on the platform, right, when I'm buying certain things, and so on and so forth. Similarly, on the other side, on the seller side, there are several modules are there, right? For example, how do I know that a particular seller who is coming in is actually bringing in the right quality products? Is she bringing high quality product, medium quality product, low quality product? And how do you do the gatekeeping and to ensure that good quality products are only getting kind of sold in the platform? How do we increase the selection or the product diversity on the platform by bringing in diverse seller groups, right? How do you onboard them, and so on and so forth? Then in between, these half checkered boxes are essentially the components which have relevance on both consumer side and on the seller side, right? For example, on the top left that you see trust. Trust is essentially what also known as like fraud detection and prevention. So the reason I use the word trust is essentially how do you ensure these hundreds of thousands of sellers or hundreds of millions of consumers, they have trust on the platform to do transactions, right? I mean, paying money for something which we don't have it, you're not touching it, and expecting that something to come to you in a day or few days time, which is actually a big barrier, and probably what we see, that why there is a gap between a number of people watching Instagram Reels versus actually buying products on the platform. And on that, and then doing that, right? So that's the aspect of trust. And trust often we kind of look in from a consumer side, right? That we as consumer we don't need to we don't get cheated, right? But similarly, there are trust issues on the seller side, right? There are many times consumers do certain things which are not fair, right? They return a valid product. They use a product from sellers and then return that, right? And so on and so forth, right? And you know. Similarly, you have customer service, acquisition, and retention. How do you acquire new customers, new sellers, right? How do you do personalization for sellers and consumers, right? All of these are like essentially big areas in which these companies. And then finally, what you have is the central backbone of these platforms, right? E-commerce, as we interact, is an online interfaces, right? Everything else that I talked about, still everything can happen online. But still at the end, you need actually certain physical goods to come from one place to your doorstep, right? How does that supply chain works? The online to offline translation and these offline coordinations and across these more than 99% pin codes in India, how does these products actually go through, right? How does the supply chain work? What does the inventory planning work? How does accounting work, and so on and so forth? Is essentially kind of bringing in the completing this whole picture in the online to offline world, right? So that's is a high-level schematic of a large-scale e-commerce platform. As you can see that I have grayed out a few boxes, right? And there are a few important components which are missing on the central backbone on the consumer side, on the seller side, right? Anybody would like to guess what is this component number 1, which is part of the central backbone, but it's not mentioned there?
Maybe something to do with the warehouse.
Yeah, something to do with the warehouse. Yeah, it's a good guess. I would say, but inventory planning is something probably is more about the warehouse management in a way, and also the supply chain. Sorry, there was another guess.
Fulfillment.
Fulfillment, yes, important area for the thing, but supply chain is broadly the domain, right? Is where we kind of get stuff, transfer stuff, and fulfill customer wishes and their orders. So the point here is the forecasting and planning, right? How do you know? I mean, we are dealing with like hundreds of millions of products. How do I know in this everything store what is going to sell? What should we have in our warehouses, and in which part of the warehouse, so that we can quickly fulfill customers' wish? Today, customer wants to place an order and they get stuff in 10 minutes, 1 hour, within the same day. So you need to have this stuff, right stuff, very close to the customer, right? How do you actually bring that? Similarly, on the seller side, right, there is something that is I have grayed out, right? This is again an important area, right? I'll probably go ahead and say that in interest of time, but you may want to think about the consumer side. There is one part that I have blocked. So the pricing. How do you price products, right? I mean, it's a competitive market. There are various pricing levers and a digital commerce company can employ, right? How do you price products so that your certain business objectives with respect to, say, revenue, profitability, maybe customer satisfaction, right? Those things are served well, and these are not like in a small scale, right? These are again tens and hundreds of millions of products that you have to do. So you have to do this in an automated and intelligent manner. So how do you actually build pricing solutions there? Any guess on the consumer side? There is one very important aspect is missing when you go to a consumer. When you go, just think about an e-commerce platform. You go, what do you do?
Customer profiling.
Yeah, that's an interesting point. Customer profiling. I would say that kind of comes under this personalization aspect. So you know, right? Okay. I mean, as a platform, I should know you well, so that we can actually use your profile well, so that I can serve relevant products to you. But when you go to an e-commerce app or a website, what do you see?
Is it recommendation?
Yeah, personalization, recommendation, these are kind of related. And that's why actually, by the way, this is something important to note, that this is something applicable both for consumer as well as sellers, right? Sellers also want to know what they should bring to the platform so that it sells well, right? As a business, and e-commerce companies, because of their wealth of data, etc., they can do these recommendations well. So they bring in that. But when you go to an e-commerce platform, maybe you guys are thinking very deep. I was talking very simple stuff, right? when you go to an e-commerce platform, the first thing you see is that a catalog, right? I mean, a deep hierarchy of products, right? In terms of like, okay, mobile, electronics, furniture, and so on. Then you click on electronics, then you go into laptops and whatever accessories and printers and so on, and then click again, and then right. So this is a huge tree or huge forest that is there, right? How do you actually manage that structure and making sure that continuously you are able to serve the most latest and the correct display of your product repository is again a huge problem and lot of work that goes on there, right? So with this picture is complete, and I just wanted to kind of now get into like I'll get into specifics of a few, but I just wanted to say that this is a representative, it's not comprehensive. There are other areas, like for example, some of you what we're talking about, like customer profiling, user insight generation, recommendation. So many of these are like kind of overlapping with some of these, but there are many other things. So it's a good representation, but may not be comprehensive. But the other important point here is that from a data science, machine learning perspective, each of these areas have, I don't know, few or tens of problems which are getting solved in the e-commerce context, right? And that is where this data science is such a pervasive requirement across the e-commerce funnel from seller side to customer side is a point to be noted. Now, what are these, right? I mean, of course, we'll not be able to cover everything. So I thought that I'll kind of go over of some of the modules to talk about that. What are these, some of these problems, right? So let's start with this forecasting and planning, right? So how do we do that, right? What is the data science areas that is there, right? So forecasting and planning is essentially, as we know, right? In simple terms, forecasting is essentially knowing we have some historical data about a trend, and then how is it going to look like in the future, right? In the e-commerce context, forecasting and planning is multi-level, an iterative process that kind of goes on almost throughout the year, and with a strong interdependencies between. Right. And again, I've just given some names, right? For example, to do the long-term planning for business, right? You would like to do what is known as the demand planning, right? Essentially, it is talking about like things like, how many audio products will sell in the month of October overall in India, right? So I know that, okay, this is the volume of the products that we will be able to sell in the audio products, right? So how do you predict that? But once you have that, you also need to figure out what is known as a more finer granularity planning, or essentially the demand forecasting, is that I know that this is the volume of the audio products that we're going to sell, but how many of the Apple AirPods are going to sell on a particular day, say 18th October, in and around Kolkata? Why is it important? Because I want to make sure that I have the right amount of repository, right amount of products stored near to that date, not too early and definitely not late. And they're stored close to Kolkata, right? So that once people place the order, I don't have to fly that in from, say, Delhi or Chennai or north or south parts of India, right? And how do you actually do that? Similarly, as you are getting the demand side of things, so how do you actually serve these demand, right? What is the capacity that you need in your supply chain network, in your warehouses? How many people we should have? How many delivery executives should be there? How much of the truckloads of stuff that needs to move from one place to another, right? And so on and so forth. So a lot of integrated capacity and resource planning is also kind of comes under the planning point of view. And finally, the inventory planning and placement. The placement is often under-emphasized in the context of planning, but placement is super critical, especially as consumers, our expectation of delivery speed is becoming increasingly important, right? We don't want things to come after a week. We want it tomorrow, and hence, like placing the right place in a network of warehouses that large companies have is becoming increasingly important. No, but why is this a challenging problem, right? And because while we understand that many of these are prediction problem, optimization problem, dealing with which can be solved with machine learning, but why is it a challenge, right? So one is that this near infinite selection of e-commerce platforms, right? I mean, there are like the hundreds of millions of products which are there with a very diverse range and with a very different life cycle, right? A life cycle of a grocery item like a packet of paneer versus a life cycle of a mobile phone are very different, right? Many of these are very interrelated, right? I mean, mobile phones, there are so many varieties. A new mobile phone getting launched can affect the sales of the other platforms, other mobile phones, and so on and so forth, right? So how do you actually deal with this kind? I mean, this is a large scale demand forecasting problem with a very, very, very diverse engine. Secondly, this is a very dynamic and to a great extent unpredictable ecosystem. There is tremendous volatility in demand and the supply chain. Consumers are getting at a huge velocity in the ecosystem. Sellers are coming and going from the platform in a very, very things. There are natural calamities. There are like fluctuating demand, one-time demand, right? I mean, maybe books on cryptography were probably, sorry, not cryptography, so cryptocurrencies were probably more popular 5 years ago than now. Or like one-time product like this fidget spinner, right? If you remember, right? The people used to do this thing. They were like huge trend. So suddenly they are out of trend, right? How do you actually kind of deal with such tremendous volatility in a thing? Similarly, these pricing fluctuations, right? Always the pricing is changing on this platform with discounts, offers, promotions, and then products are getting out of fashion. New models are coming in. So it's not a very steady ecosystem in which you can you are doing the forecasting, and as a result, learning from data is also comes with its own challenges. Large combination of granularities across product, time, and geography dimensions. So you are, as I was talking about, right, demand planning is at a higher level, forecasting at a smaller level, and so on, right? And we say that there are 3 mantras towards like intelligent solutions of forecasting and planning. It should be agile. It should be able to, like by agile, I mean like it should be able to respond to changes very quickly. It is very connected, like many parts of planning and forecasting are there, that how they are interacting with each other is extremely important than treating each of these problems independently. And intelligent, like, I mean, how do you actually learn from data and being able to build intelligent forecasting system is extremely critical. Again, I'll probably skip this slide. I mean, forecasting techniques have been existing for many decades, and the forecasting techniques have also been evolving. I mean, from knife forecasting to statistical forecasting, machine learning has become more and more common. But of course, like everything else in life, in machine learning, deep learning for forecasting has also become very, very popular, right? I mean, some recent work has showed like very superior performance of deep learning-based forecasting, going beyond like the standard statistical univariate and independent series modeling, right? So neural architectures have claimed to model these inter-series dependencies, like to extract what we call as the higher order features, identify complex patterns within and across time series, which is extremely important because, as I was telling you, right, these are not, you are not predicting for one series, you are not predicting for one independent series at a time. Rather, you are dealing with many large number of series which are very strong dependencies and very high intercorrelations are there, right? And not only people have come up with like traditional, I mean, new deep learning based techniques, but they're also kind of using techniques which are developed for completely different domains, and people didn't probably think about this kind of applications coming from natural language processing and such techniques like this RNN, LSTM, seq-to-seq transformer. All of these are found like applications in the forecasting domain, right? Let's see, like maybe I'll go through like some of the sample paper, like in terms of like what are these kind of papers. So one of the very interesting paper that I saw like a couple of years, a former colleague of mine had written is this application of the graph neural network on the for forecasting. So basically, they essentially they're the problem they want to solve is what we was talking about, right? This dynamic environment, right? That launch of competing or similar products can affect the demand for one product, right? Price increase or decrease from one seller can affect the price demand for another seller, right? Things which are not an individual product is doing right or wrong, but the other, right? So these people actually kind of consider this interdependencies between sellers and product. They're represented through like a large hypergraph of product and sellers, where they captured like these different, so basically there were different nodes of product and sellers, and then interdependencies between demand relation, that one seller is selling a product, or substitute relations between two products, and so on, right? And then through this hypergraph, they use this graph neural network to come up with higher level representation, and then a bunch of LSTM and MLP, multi-layer perceptron, they essentially come up with the final prediction, right? So their goal, while the GNN was used to kind of get a appropriate representation, but they have been able to show that across the board, with the very prominent ones in difficult scenarios, such as this multiple sellers offering the same product, or products which are extremely new, there is no history associated with it. How do you predict the demand for those, right? So that is a very, very, very interesting work that kind of came presented in this work. There's another work that is early papers from Flipkart on this associative and recurrent mixture density model, right? It's basically, again, the notion is that how do you take into account similarities of different products to come up with the forecast for one product while leveraging similarities of the other products, right? And that is the difference from the classical forecasting techniques to when you deal with these e-commerce scenarios and so on. Sequence using image and structured features from IBM. One of the state-of-the-art paper is this called this temporal fusion transformer, or the TFT. So it's a transformer-based model, which has like this multi-head attention to capture this temporal dynamics of multiple sequences. Again, my intention is not to get into the details, but again, it handles like this complex mix of inputs in terms of that which is present in real life forecasting scenarios in a very effective manner. Now, while I talked about like all the deep learning based techniques, right? In practice, how well they work is to be carefully considered, right? So it's one thing to know about like, okay, what is their accuracy, right? But also there are other factors like cost of training or explainability of these techniques, right? So, and there have been some contradictory evidence, right? So, for example, this particular paper, a simple combination of univariate models, they essentially compared a various implementation of a deep learning technique and quote unquote simple combination of univariate models, right? So even at the end, they saw that in the best setting, the deep learning model kind of gives lower error than the statistical forecast model. Instead of 12.63, there's 12.27 is in the final row. But they also bring out that interesting aspect that this deep learning ensemble took more than 14 days to run and basically to train, and costed around $11,000 than the statistical ensemble model, which took some time to run and some cost. Quick question: any guesses like how much time that a simple model would have taken to run, and why? And given that it's a big deal I'm talking about, so it must have taken less time and less money. But any guesses how much it might have taken? How much time did it take to run, to get trained? Any guess? The deep learning model took 14 days. Did it take 1 day, 2 days, 10 days? And it was done on a reasonably large set like M3, the time series forecasting competition, M3 competition. Some 3,000 series are there.
Maybe 4 hours.
4 hours, okay. Sure, that's a good guess. It took an order of magnitude less on that, but actually it took even order of magnitude less than that, right? The ensemble took 6 minutes to run and costed $0.50 compared to this 14 days and 11,000 USD to get a gain of 0.36 points of error, symmetric MAPE error. Now that's an improvement. Nobody questions that. But in practice, is it worthwhile? May or may not be. Maybe it can get a paper because the accuracy is better. But in an application, is it better? We don't know. Similarly, another observation was done that are transformers effective for time series forecasting, where this is the title of the paper, and I think it came last year sometime. And basically, these guys compared a number of deep learning techniques here, and couple of like what they call as the simple linear model, D-linear, as the comparison, right? And basically, the best results are and these are, each column is a data set. And the red ones are the best, and the blue ones are the second best. And the first two rows are their D-linear implementation into two implementations of that. And you can see that most of the red and the blues are in the top two rows. Of course, there are some settings where the other deep learning techniques are kind of getting better. But again, it looks like the simple techniques work quite well, right? So that's why I kind of like to call this as the jury is still out. So while deep learning has shown superior result in many papers, but there are counterexample always. And I always advise that people to actually kind of try out state-of-the-art statistical and ML techniques before adopting a DL-based forecasting. I'm nothing against deep learning, but blindly adopting it also without considering other aspects of practicality and interpretability and so on is not the right approach. Okay, let me see what is the time. Okay, let me go into the pricing part, and then I will see that if we can cover another segment on that, right? So the second part I thought that I'll talk about a few examples is the pricing. So pricing is a product, right? I mean, why is it a problem, right? We get prices of, I mean, there are some prices you can see that are associated with the product, right? But not always or rarely you buy product actually at the price that is written there, right? There is always some discount is there, which is offered by the seller. There is some discounts is given by the platform. Maybe sometimes certain credit card that you have will give you some offers and so on and so forth, right? So how do you, I mean, so there is some flexibility that is there that a platform can actually price a product, right? So how do you do that? Is a very important business problem, because you need to if you price it well, if you price it too high, the product will not sell. Or I mean, you may be increasing your profit margin on a product, but your product may not sell enough. But if you price it too low, I mean, you may be leaving money on the table while selling a lot of product, right? And of course, on both sides, you have people who have opposite expectations, right? Consumers are always looking for products which are least priced across the board compared to the other option. Similarly, sellers are saying that, okay, if I could sell it a little bit higher price, then I'll make more money, right? So how do you actually do these recommendations on the sellers at the time when they are listing their product? Similarly, how do you actually shape customer demand by offering the right price is an extremely important, at the same time it's a challenging problem. So both there's a prediction going on, like what is the right price of a product, and similarly there is an aspect of optimization that is going towards certain goals, right? That how do you price product on, even if I consider this one product, how do you price the product which gives you the highest with respect to your business revenue or profit margin or so on. And we're talking about here, again, very large number of products which also have interdependencies. So increasing the price of one phone may affect the demand of the another competing phone, and so on and so forth. So, and that's why these dependent sources of complexity are there. There are various factors which determine the price of a product, right? From brand, quality, supply and demand. What has been the production cost and volume, right? Is it something getting produced huge or versus very rarely produced, right? Or if I go back to that rare example of the fidget spinner, right? At one point in time, the demand was growing like exponentially, right? So you get a lot of fidget spinner across the country because they are selling very high. So you want to sell to your customer very, very fast, right? But then within a month, the demand like completely goes away, and then you are left with a lot of fidget spinner. Now, how do you actually discount them, right? What is the right way to discount them so that you can actually at least salvage some money, or eventually you might have to give it back to the vendors and so on and so forth, right? So again, so those are these the demand has a very important aspect on the how do you also price. Frequent price changes owing to the above factors, as well as the sales and promotional events, right? Continuously there are sales and promotional events that are going on, right? I mean, and yeah, given that I'm representing Flipkart, the Big Billion Days are coming up very soon, which is our annual festive sale event, right? And very soon you will be able to see that there are like huge number of products that are available at a very high discount and so on and so forth. So you can kind of target those, right? Competitive pricing through catalog matching, right? I mean, how do people actually kind of see that, okay, here is a platform that is selling at price X, right? I should sell at X or less than X, right? And that X is also constantly changing because everybody is kind of trying to eye on each other to see that, okay, what is the right price that is. And again, so there are multiple lines of research that has happened. One of the ideas is essentially around that prediction of price, right? So given a product, how do I know what is the right price for that product, right? So for example, this first paper from Alibaba, they talked about this, how do you price this for their second-hand items. This was for the second-hand items product, and which is where actually the price prediction becomes even more important, right? So, and they came up with this two-step approach where they first, based on the image and the textual features, they try to see that whether there is enough information or enough confidence I have to be able to actually predict the price of that product. And then if it is confident, then again, based on those descriptions, it kind of comes up with what is the right price for that for that product in a way. Similarly, there's the fashion e-commerce Myntra. They have this interesting paper called this for price optimization in fashion e-commerce. So where they have a demand prediction model, they first try to kind of estimate the demand maybe as a forecasting model. Then basis the price elasticity of the product, they try to obtain what is the demand going to look like at different price point, right? So for a t-shirt, if the demand at the price of 500 rupees is 200 units, then if we price it at 400 rupees, what will be the demand? If we price it at 600 rupees, what will be the demand using the price elasticity of the product? And then choosing the most optimal pair of the demand price pair, which kind of gives you the highest highest revenue or GMV for the company, right? So that's the basic idea. Of course, there is again much complexity involved as you are doing it for many products which have substitutability and complementarity relation associated between them. And similarly, like the community marketplace like this, Mercury and Kaggle, they had offered a product competition on the price suggestion challenge. Airbnb had a product. I think there is some issue, but Airbnb had a similar project on the homes and experience, right? That what is the right rental price for a hotel for a Airbnb house that they came up with. Yeah, so so there was an error in the, okay. So as I was saying, that pricing and demand forecasting are highly interdependent, like one fuel sales in the low demand period, but at the same time, you need to consider that how do you regulate supply and demand. So pricing gives you that lever to kind of regulate the supply and demand. Significant variations in relationship exist between the price and demand across different categories, like hard goods versus perishable, right? I mean, the kind of leverage that you may be able to do for a hard good like a furniture versus perishable, a pack of paneer or something will be very different because you cannot store a perishable stuff for a long time, right? So that's the kind of interdependency between these two systems. Okay, I was supposed to stop at 8:30. Maybe I'll just take 2-3 minutes, just quickly talk about the product catalog as why is it what it is, right? I mean, so product catalog, as I was saying, right, when you land on a product page, right, this is a large taxonomy of products available on the platform, right? Now, here sellers are adding for products, adding products, and those are getting listed under different categories and subcategories or sub-subcategories, and for people to kind of go and browse through. So other than searching, catalog browsing is the other second most common way of finding a product. Now again, this is a huge size, right, with thousands of leaf nodes and 5 to 10 levels of depth, where hundreds of millions of products kind of get into this level, right? So, and each of these products are described with maybe 10 to 100 attributes as they are getting into, right? Now, it is not possible to do manually. One is because of the scale. The second is because of this is a high velocity of addition, deletion, and updates, right? I mean, you can imagine at this scale, the number of new products are getting added to the taxonomy is very high. Maybe thousands or tens of thousands of products are getting added every day. And similarly, products are getting obsolete, right? I mean, you don't want to show an old-fashioned T-shirt from 5 years ago, which was added. And how do you actually make sure that the cat taxonomy is always up to date throughout, right? And similarly, it's a from machine learning scientists, it's a very, very lucrative and challenging large-scale hierarchical classification problem. And again, with a highly imbalanced number of samples, not each of these nodes and subnodes have the same number of examples that are there. An interesting offshoot problem that comes in often after a catalog has been created, you have a search function which runs on top, right? Now, how a product is described by a seller versus how consumers look for the product is very different, right? I mean, when a seller describes a printer versus when a customer is looking for a printer is very different. But one is very specification heavy, another is very functionality heavy, right? So how do you actually do this vocabulary mapping and the right search and so on? Maintaining correctness, uniqueness, and recency, as I was talking about this constant addition and deletion. And off late with the more, I mean, it's not a textual thing anymore, right? How do you do visual search, multimodal search, code mix search, especially in the Indian context? Code mixed queries are just like web search is very popular. I mean, very, very common. And in the context of product, like they come in like really all forms and shape as people deal with these. Okay, so I'll skip the details part of it, but let me just quickly summarize here that, as I was saying, that e-commerce is poised for very big and bigger growth in the coming years, and where data and technology are playing strong enabling roles. I mean, data is not to answer the questions like if and why we need data science in e-commerce. It's evident that the scale and the diversity of the interactions that are going on in this platform is not only a gold mine for data scientists, machine learning researchers, engineers, but also without them, it does not, it cannot maybe survive or exist, right? It is extremely rich in data and richer in problem statements. And the various subfields of AI, machine learning, data science have made significant breakthroughs and more to come in line with growth trends. So it's a very, very active field in terms of the domain. So a lot of research, lot of workshops in the conferences which are very much focused on these e-commerce applications of data science, machine learning, natural language processing, computer vision kind of goes on. So with that, I'll stop, and we'll be happy to have any question that may be there.
A question from the audience. One time you can take one or two questions only. You want?
Hello. Can you hear me?
Yeah, I can.
So it is a great talk, and I'm seeing that e-commerce is moving to a totally new level with the introduction of this AI-generated query response and many other, things that are coming. That first level handling of queries are done by AI-based techniques and many of those. So how do you see from the industry perspective, is the online portals of businesses, are they rapidly trying to find how they can use AI? Is that for their benefits, not only in terms of marketing and sales, but also improving efficiency in the business in all aspects?
Yeah, absolutely. No, thanks for asking the question. It's I mean, I would say that absolutely yes. It's an imperative that the e-commerce and the retail companies can leverage AI data science for all aspects, and not only for the sake of saying or for PR purposes to the world. And as I was saying, right, it's probably no longer an option not to use these in their core operation to bring in efficiency or to bring more effectiveness, but rather many cases this is just not possible to do it without machine intelligence kind of folded into these.
Mhm. And do you see, again, I'm from a different perspective, I'm seeing a large number of people all across the world that they are using AI as kind of a black box. And there is nothing that AI can do as a black box. And there are a number of dangers to that. There are a lot of fine tuning is needed, parameter tuning, configuration, and the way companies are marketing that you just download this and get your business done. Now, do you see there is a risk involved in that?
Yeah, I mean, okay. I'll probably give a little bit of generic answer right here. I mean,
yes.
In this case, I mean, anything is as a black box is probably not the right way to go about to act when you are using something for as fundamental as running your operations. Just like every other domain of AI, interpretability, explainability of the models have become crucial in the e-commerce segment as well. In fact, as one of the things that one of the paper that I was recently reading, that TFT paper that I briefly referred to, one of the key selling point for them is the interpretability of their model, right? I mean, when you are predicting that here is how the demand is going to look like in a particular day on a particular segment, why it is so, on what basis we are doing, and that gives, as human users, better, more confidence in terms of that the machine's decision is probably correct, right? It's kind of giving you a rationale behind the prediction than only giving the prediction, right? So yeah, so the generic answer, yes. I mean, it's not only black box, but rather kind of getting deeper into it. And
right. And our effort that to encourage the young generation deeper understanding of this method, not like download the software, whatever it is, and just run kind of garbage in, garbage out kind of experiments, rather understand what is doing. And each of those AI algorithms has their own advantages and disadvantages. And I don't know how the industry is moving towards the generic kind of selling points. And so here is my, and thanks for coming and participating. And we have every month, and I really appreciate if you also feel that it is important to give the knowledge to the next generation in a way they are, they know what they're talking. So all companies are desperately looking for the skill set. Whoever can run this, they're hiring, but they don't know. They cannot go beyond certain level. So our effort is to bring to the industries that here is a large number of universities in around Kolkata and in the country where the talents are there, but they are looking for opportunities to explore and expand their horizon. What do you think? Will it be possible, or it is like a daydream?
Sure. No, absolutely. This is a definitely laudable initiative. And I appreciate all of you doing this, and definitely for inviting me and making me a part of today's session.
And lastly, in December, a couple of people from industry and other areas in the region is trying to have a face-to-face exposure on bringing the experts from industry. Here are the job opportunities. Here you can. So do you think your company or you will be able to participate in some capacity, promoting your company or giving a talk to the young generations like this? What do your thought on that?
No, yeah, sure. I mean, I have been associated with several community activities, especially with the CKDD India chapter over the
Right.
year. So I definitely believe in this large community involvements between, especially cross-cutting academia and industry. So something that I quite actively do. Again, I mean, the specifics would depend on like what is the venue and what is the session about.
Right. And TCS R&D is very supportive, and Dr. Arpan Paul feel there is a lot of opportunity for young faculties, young researchers, and next generation. Though a lot of things are going in Hyderabad, Bangalore, but Kolkata is still a fertile land with full of opportunities. So that is the thought process. And Saurabh, do you have anything to add, if we can be involved?
Yes, I really enjoyed the talk, and I would love your participation in the December event if that happens. The question-wise, I have a quick question. I really liked that you're using graph. We use graph a lot in risk modeling. We are doing a project with Hitachi where we are doing a lot of risk modeling using graph-based representation and graph convolution networks. So this graph neural network that you have done on stages, how do you actually build these graphs? And question is, do all the companies like Amazon and Alibaba are models are all built on graph? Because graph is coming up, knowledge graph and all are coming up very heavily in the industry. And so how popular is this graph-based representation of the data?
Sure. Okay. So firstly, to a disclaimer that the particular work that you are referring to, that's not my own work or our own work. It came from some scientists from Amazon. But taking the broader perspective, you are absolutely right that graph as an extremely powerful data structure, and with the downstream techniques in the form of, say, graph neural network or GCNN and so on and so forth, they are becoming extremely common and commonly used in the industry. The other part of your question, that how do these graph structures are kind of created? I mean, while I would imagine that the static graph creation is probably less of a problem, but how do you actually keep it up to date, right? With that such high velocity of sellers and consumers coming to this network, and their interdependencies between sellers, products, and consumers are constantly evolving. How do you know at every time point that you are actually doing a certain convolution on top of the structure of the graph that you have? The structure itself is the most latest and most correct at that point, right? So
1 minute though. However, there's something called graph attention network that actually does the edge detection and node creation automatically, really. And it's very much used in Facebook for social network and Google and Twitter. All the underlying structure is graph, really.
yeah,
And
absolutely.
so graph attention network can be used to address the problem that you said. But I don't know how much the industry is using. In academia, we use a lot.
Yeah, you mentioned, yeah, absolutely. I didn't want to get in like too much of a detailed part of it here, but as you rightly mentioned, right? I mean, many of the large companies are actually already using it, right? And the e-commerce brings in some additional challenges, right? In terms of the heterogeneity of the graphs, right? In terms of how do you, I mean, these different kinds of entities that are there, right? I mean, sellers, consumer, products, and their interdependencies. I'm not saying that it is not possible, right? It's just that both doing it in large scale and being able to manage this updation in a continuous basis, you need things like graph attention network to actually be able to deal with that. And industry is actually, in my opinion, is also rightly placed to do it because of the large volume of data they have and so on and so forth.
Right. So in that, again, in the December event, if it happens, I would like you to present something on this area, actually. The way you said that these, because this is a very good application of deep learning, and it actually is giving results, right? And weather prediction is also giving similar things have been applied in weather prediction, and it's giving results. So that it will be very well, appreciated by students and people in the industry to see something like this. This is really real AI in working. So if you can get involved and do some community work, that would be very much appreciated.
I'm glad to know that. No, thank you, Professor Kundu. Yeah, do let me know. I'll definitely consider and
thank
see.
Thank you. Over to you, Professor Dasgupta. That's all I had to say. Thanks.
Thank you.
I think I have all the questions. So
anyway, all the audience participants over here are requested to fill up the feedback form. The link is given in the chat box. Request feedback from your end for improving the future webinars and topics you can suggest also in the form. So anything, I hope that everything we have covered up all the lecture schedules for today's sessions. And what do you, Somnath?
Hello, sir. Am I audible?
Yes, please conclude it, please.
Yeah, thank you, everyone. We are honored to have the presence of numerous distinguished individuals at this IEEE CIS lecture series tonight, session 5 on artificial intelligence and evolving intelligence systems. Today, as we host the 5th session of this lecture series, we are proud to witness the participation of renowned researchers from both academia and industry. Their insightful presentations have given light on the contemporary research challenges and opportunities in the field of intelligent computing, greatly benefiting the participants. Moreover, this series of monthly events have successfully facilitated the formation of consortium, bringing us closer our goal. We extend our heartfelt gratitude to the consortium led by Professor Dipankar Dasgupta and Dr. Arpan Pal, comprised of esteemed researchers from esteemed institutions. Their active supports have been indispensable in bringing this event to realization. We'd like to express our sincere thanks to Professor Sudeshna Sarkar of Indian Institute of Technology, Kharagpur, and Dr. Saurya Roy of his senior research director at Flipkart for their comprehensive lectures and engaging discussions today. We'd like to acknowledge the dedication of Professor Siddhartha Bhattacharya, Chair IEEE CIS Kolkata, who graciously chaired and moderated the lecture sessions despite his busy schedule. Our gratitude extends to all the participants who contributed to the success of these lecture sessions. Your support has been invaluable, and we hope to receive even more encouragement and participation in our future lecture series and events. Lastly, we would like to express our appreciation to the IEEE CIS Kolkata team and IEEE Kolkata section for their solid support in organizing this lecture series and other events. So thank you all once again for your invaluable contributions and support like before. Thank you so much. Good night.
Thank you.
Yeah, thank you.